Hey guys, it's Sierra. I'm doing my practice Microteach for EDSE 4275. So class, last time I asked you to look up polymers and get a list of them. So I want you at the beginning of your notes for today to write down as many polymers as you can think of. If you didn't look them up at home, try and just think of some. But I'll give you about a minute to do that. Okay, is everybody done? Okay, the objectives for today are going to be, I want you to connect polymers to your everyday life, and then I also want you to explain the characteristics of polymers. So who can give me a couple examples that they wrote down in their notes?
Plastics.
Plastics, okay, that's a good one. What about another one?
Proteins.
Proteins, what kind of proteins?
Like the ones in your hair.
Your hair, where else?
Fingernails.
Fingernails, yeah, good. Okay, what's another one?
Rubber.
Rubber, yeah. So if we look around this room, we should see tons of polymers. So who can point out one in this room? The shirt you're wearing. Everybody's shirts has some sort of polymer in it, whether it's natural or synthetic, which we'll get to later in the class. Also, the tables you're sitting at are made out of wood, and wood's a polymer. Who can think of another one around here that might be a polymer?
Maybe your shoes.
Your shoes, because they're made out of rubber, right? The soles of them are made out of rubber, so yeah, good. Okay, so the activity we're going to do to start out today, I'm going to get you guys into groups of 3 or 4, preferably 3, and I will give you a diaper. Now, why would I use a diaper to showcase polymers? Does anybody know? So, when you have a baby and it has a diaper on it, it uses the restroom and it's absorbed into the diaper. Okay, so that powder, that compound that's in the diaper will absorb the water and it's a polymer. So I'm going to pass out some diapers for you guys, and you're going to cut them open and put the powder in a cup or a beaker, and then I want you to see how much liquid that powder will hold. Okay, so I'll pass out your materials and we'll get started. Okay, now that we wrapped up the activity, what are some of your thoughts on the diaper and the hydrogels that were in them, the powder?
They can hold a lot.
They can hold a lot, right? So they've been designed very well to be used in diapers to absorb liquid. What was the liquid you guys got?
About 500 milliliters.
500 mils. Was that a lot to you?
Seems like a lot.
I think that's a lot. Okay, so let's take a few notes. So in your notebooks again, let's talk a little bit about polymers. So, what do we think the word poly means?
Many.
Many. Good. What about the word, or the end side of the word mer? Any guesses now? Okay, so mer means parts or segments. Okay, so that makes sense. We have many parts. So to make up a polymer, we have to have the pieces that make it up. So they are made up of monomers. So if we have tons and tons of monomers, they make up polymers. So what do we think mono stands for?
One.
One. So if we have one part that makes up many parts. Okay, so lots of monomers make up polymers. Everybody got that? Okay, cool. Let's draw kind of a cartoon of what polymer would look like. So our little squiggly at the beginning is going to show that the polymer keeps going this way, but we're just going to draw a chunk of it. So we have a line, A monomer. One. Okay, so all these little guys are the monomer, and this whole thing is the polymer. Does that make sense? Okay, so another term for polymer is a macromolecule. Okay, why do we think this would be an interchangeable word for a polymer? What does the word macro mean? Does anybody know?
Really big.
Really big, right? So we have micro and macro. Micro is really, really, really small. Macro is really big. Okay, so if we have a large molecule, that would be lots of little molecules made into one big molecule, just like proteins in our body. We know from biology class that your proteins are a largely macromolecule in comparison to one small part, like your DNA or something like that. Okay, so an example of a polymer is polypropylene. Okay, so let's draw this structure. You know, we've drawn our Lewis structures in class, so we know how to do this. So our little squiggly starts it out because that shows that it goes this way. And we start our line and we go CH2, CH, and then down to CH3. Keep going. CH2, CH, CH3. Do one more. CH2, CH, CH3, line, and squiggly to show that it keeps on going. Okay, so this is just an example of the chemical structure of a polymer. All right, so now let's talk about the two main types of polymers. We have natural versus synthetic. Okay, so kind of self-explanatory, but what would be the difference of them? So natural,
Made in nature.
made in nature, Okay, so what are some of the examples that we discussed earlier that would be a natural polymer?
Really? Trees.
Trees, okay, trees. So they're made out of wood, just like our tables. That's another one. Natural.
Proteins.
Proteins. One more. What about what makes us all different?
DNA.
Our DNA, yeah. So we have our DNA, and then I'm also going to put RNA. Okay, so these are all things that are polymers made in nature, and what makes them more of a natural polymer is that they are water soluble. So what do we think a synthetic polymer would be?
Made
By someone. So who do you think would make this?
like a scientist.
A scientist or even engineers make them, or design them at least, okay? Okay, what's an example of a synthetic polymer?
Nylon.
Nylon. Where do we find nylon?
In their clothes.
In our clothes. So what's another polymer found in our clothes?
Polyester.
Polyester. Yeah, you've heard that your shirt's made out of polyester. Okay, we see that the beginning of this word is poly, just like a polymer. Okay, there's many of them. What's another one we can think of? What? Teflon. Who's heard of the term Teflon? Who knows where Teflon's at? Okay, so at home when you're cooking with your pots and pans, there's that slick coating that's on it. That's known as Teflon, Teflon coating. Okay, so that's a type of synthetic polymer. Okay, so we've gotten all of these synthetic polymers because of what we know with the natural polymers. So we take the structure of a natural one and we try and duplicate it to get our synthetic. A natural polymer that is currently in research is Chidin. Okay, Chidin is the polymer that makes up the shell of lobsters and crabs and shrimp, the stuff we eat. Okay, and what makes this natural polymer so interesting to scientists is it's hard, insoluble, and flexible. Okay, so we have scientists and engineers working with this polymer because it has these three characteristics. So it's not like these ones, it's not water soluble, it's insoluble, and it's hard yet flexible. So they're trying to make a synthetic product of this natural polymer. Okay, so I want everybody to get out a piece of paper and take everything else off your desk. Okay, so your first question is, I want you to draw a cartoon of a polymer. You can make it super, super creative, or you can be just as basic as the cartoon polymer that we drew earlier in our notes. And then secondly, I want you to list 5 polymers. So we've come up with tons of polymers in class today, so you should easily be able to come up with at least 5. And I want you to say if it's natural or synthetic. Okay, so I'll give you about 5 minutes to do that, and then I will collect your papers.